Welcome, everyone. I'm Eric Lanke, President and CEO of the National Fluid Power Association, and I'm very pleased to welcome everyone to our first virtual regional conference. This is a bit of an experiment. So far, it seems to be working well. I know we've got some great content and some great speakers lined up for everybody. So we hope people have a productive experience this morning. It's clearly been a challenging time for our industry and for our nation. And at this time of unrest and uncertainty, I want to make sure and send my best wishes out to everybody. Hopefully everybody is healthy, safe, and focused on helping to bring about a better future for their businesses and for our country. Over the last several months, it's really been demonstrated to me that fluid power manufacturing and manufacturing more in general is a core and essential part of our economy. And I'd like to believe that a lot of the opportunities that exist in our industry and in the wider manufacturing community can continue to be a positive force as we move forward in these difficult times. It's not coincidental, and it's very beneficial, I think, that we have precision manufacturing teed up as our topic for today, specifically precision manufacturing and its impact on fluid power efficiency, reliability, and durability. That is one of the topics that came off of the NFPA technology roadmap, one of the areas that we've seen some advancements that are beneficial to the fluid power industry. That roadmap is, of course, the source document for a lot of the content that we present at these regional conferences. And our goal is to present our members with market-ready technologies that are available and are already shaping the fluid power industry for the better. I'm going to turn it over to Tom Wanke in just one more minute, but before I do that, I want to go through some quick housekeeping announcements. I think if I figure out what I'm doing here, people should be seeing the housekeeping announcements on your screen. So as a reminder, as a participant, you are all muted. So if you speak, we can't hear you. So your two mechanisms for communication are the Q&A box, which we would ask that you reserve for questions to the presenters. You can feel free to ask those questions as the presentation goes forward. Pete Alice of our staff will be monitoring the Q&A box and will be appropriately interrupting speakers with those questions so they can be addressed either as they occur or in his judgment if they need to be handled at the end of each presentation. The other option is the chat box, which I see most people are using already. If you haven't done so, please introduce yourself in the chat box. That's a great way to network with everybody else that's online. Denise Husenica of our staff is going to be monitoring the chat channel and will be helping facilitate those discussions and those conversations. As a reminder, our session is being recorded this morning. And that recording will be shared with all NFPA and FPIC members. So if you miss something, don't worry, it will be recorded and you'll be able to access it later. And finally, if you're having technical challenges and you just can't communicate through the Zoom channel that we've set up, there's an alternate strategy for you. Another member of our staff, Maddie Paris, is on standby. So her email is there, mparis@nfpa.com. Feel free to send her an email if you're having technical challenges that can't be overcome through the Zoom chat. So I think with those housekeeping announcements, I'm going to turn it over to Tom Wanke of FPIC and MSOE, who I know has some introductory comments as well. Tom?
Thank you, Eric. Good morning. On behalf of MSU University and NFPA, welcome to our NFPA FPIC regional conference on improving fluid power system efficiency, reliability, and durability with precision manufacturing. As Eric said, this is a first virtual live webinar for us, and we're looking forward to this venue. Hopefully it's going to work out for everybody. I trust everybody is staying safe and healthy and is going to make it through these challenging times we're having now. Everybody's had to make some changes, but you know, we continue to move forward. I just got a couple quick things to say. I'd like to remind people of our upcoming programs. We have September 3rd in Milwaukee, and right now we're planning a live event at Hyatt Regency, but again, it might end up being a webinar like this event. We'll have to see how things go. The topic that we have slated for September is advanced contamination control technologies for improving fluid power system efficiency, reliability, and durability. So if you're interested in presenting, you can send me an email and I can send you some detailed information on what we're looking at, but basically advanced filter medias with higher beta ratios and higher dirt holding capacity, integrated fluid conditioning systems that control temperature, remove solids, gases, water, and chemical reaction deposits, integrated sensor packages for continuous real-time monitoring of the fluid's condition, data analytics for determining remaining fluid life based on condition monitoring, and remote monitoring of fluids condition and remaining filter life. So these are some of the things of interest that came out of our technology roadmap. So if you have an interest in presenting, please contact me, Wanke, W-A-N-K-E, at msoe.edu. Following our September program, we have December 3rd. That's going to be hopefully in the Chicago area, again, assuming we can go back to live in-person programs. March 4th, 2021. We have not picked a location nor topic yet. And we have one more scheduled out to be June 3rd, 2021. And we don't have a location or topic for that one yet either. Those of you that have attended these programs before, you know that MSOE can offer CEUs, continuing education units, or PDHs, professional development hours, if you're a licensed professional engineer. So if you are interested in either receiving a CEU certificate for this program or a PDH certificate, again, please send me an email at the end of the webinar today, and I will follow up and get you a certificate back out via email, probably early next week. You also will be receiving a program evaluation survey at the end of the webinar. You'll be sent a link to a SurveyMonkey, and of course this is very, very important to us because this is the first time that we're doing a live webinar for the NFPA FPIC regional, so it's very important for you to please take part and fill out the evaluation survey. There are some questions specific to the venue as far as the webinar goes. We want to make sure that that's going to work out for everybody, and so we know how it's going to work going forward. So with that said, I think I'm going to bow back and turn it back over to Eric. I think he's got a couple other things to say before I introduce our first presenter of the morning.
That's right, Tom. Thank you for all that you've done to help put this event together. What we want to do now is experiment with some polls through the Zoom feature. We want to share some information about who is all in attendance and get a better feel, especially from our speakers, about who they're talking to. So I'm going to launch the first poll here. And somebody let me know if they can see that.
I can see it.
Yep.
So as a participant, please go ahead. We're interested, the company that or the organization that you're with, which of these descriptions best fits? Are you a supplier to the fluid power industry? Are you a manufacturer of fluid power components? Are you a fluid power distributor or system integrator? Are you a builder of machines that use fluid power technology, or are you something else? And it's okay if you're something else. We're not going to hold it against you. So the votes are coming in. About 80% of you have voted so far. So if you haven't voted, please do quickly. We're going to give that just a few more seconds. And then I'll end the poll and share the results. So again, as a test, I'm assuming everybody can see the results.
Yep, I can. Hopefully the participants can.
So about half of our audience is a manufacturer of fluid power components. And boy, we got 16% something else. So I don't know who those something else people are, but welcome to those something else people. Obviously a strong contingent of suppliers and distributors as well. Only 6% of the audience is OEMs or builders of those machines. So I'm going to stop sharing that poll. And I'm going to move on to the next question, which has to do with your role in the organization that you work for. So now we're trying to get a sense of the audience. Are you in executive management? Are you primarily in sales and marketing? Are you primarily in engineering? Are you primarily in human resources? Or is there some other role that you play within your organization? So we'll let those results, I think our participants now get the hang of this, so I see the votes coming in very quickly here. Let's give that a few more seconds. Okay, it looks like everybody who has wanted to vote has voted. So I will share those results. And maybe not surprisingly, the two largest contingents are the engineering and the sales and marketing folks. So the overwhelming majority of our participants fall into those two categories. So let me stop sharing those results. We have a third question. We want to transition and just get a sense of business activity. We know that this is a challenging time for everybody. Traditionally at these live events, we often go around the room and ask people to say a few words about the picture as they see it. So we wanted to try to replicate that. We know times are tough. The names have been changed to protect the innocent here, so don't worry, there's no identifiers on this. But since the start of the pandemic, we're curious what's going on in your overall business. We were predicting that most people are going to say down, so those where most of the choices are. So those votes are starting to come in. This is often beneficial for members to see what's going on in the wider industry to benchmark themselves. I'll give this one a few more seconds here. I see the votes continuing to come in. Okay, looks like that has slowed down. So I'll end that poll and share the results. And the news is depressing, as we expected it to be.
Yeah.
My condolences out to that 4%. That's down more than 40%. That's a very painful situation to be in, but most popular answer seems to be somewhere between 20 and 30%. But a pretty good spread across the board. I don't know that it seems like different companies have had different experiences in this environment. I guess kudos to that 5% that their business is up. We know that pneumatic valves have been very popular for ventilators and for other reasons since the pandemic began. So maybe that's a reflection of some of those folks. We also want to ask about when do you think things will improve? And try to get a sense of that as well. So nobody knows the answer to this, I know, so this is very much opinion-based. But what do you think? Business conditions will return to something approaching normal in what kind of time frame? What are you guys planning for right now? What are you thinking about? There is that impossible to say option down at the bottom down there, if it's just too challenging to know. but we'll let those votes come in. Okay, looks like those votes have slowed down. I'll give it just another 2 or 3 seconds here. So the results are a year, basically, was kind of the average, the high average here. That's challenging, obviously, and difficult, but that's the sentiment that's out there. 12% saying it's impossible to say is a fairly high number as well in this thing. So I think that's a testament to the level of uncertainty that is in the marketplace right now. And then finally, for just a little fun, after that, we need some fun, right? I'll let this one stand as written. So we all need to be superheroes at this time. So which Avenger are you most like? Think about this one carefully. It'd be great if we had like 25% in each, because then we would have the full Avengers available to us into this industry to move forward with. This one seems to be popular. The votes are coming in very quickly here.
Eric, I think this is one you should let us vote on too.
I was going to say the same thing. Come on, man.
Okay. And Iron Man wins. So there's a lot of Tony Starks out there. But a fair number of the other categories as well. So to me, Captain America is the obvious choice, right? I mean, it's like, if we can't get behind Captain America, who can we not get behind at this time? So, okay, so those are the polls that we set up. I appreciate everybody's participation. Hopefully that was informative and fun, as it was intended to be. Let me stop sharing those results. And then I think, Tom, my job is to kick it back to you so you can introduce our
excellent, Eric. And
of the day.
We're right on time. We're actually 3 minutes early. We work good. We're an awesome team.
It's like we've done this before, Tom. So
yeah, I think we have for a while. So, all right. Well, thank you much, Eric, and again, welcome everybody. At this point, we'd like to start our first technical presentation. And our first presentation is going to be bore finishing processes for improved hydraulic component performance. And this is going to be presented by Phil Hanna, Product Manager, Machines and Gauges from Sunan Products Company. Phil's a product manager with a diverse engineering project management background, 13 years experience at Sunan Products as product manager of bore finishing machines and gauges. Prior to that, 23 years of mechanical engineering, engineering management, and project management experience in a variety of industries, from electrical power generation to tier 1 automotive production. He has bachelor's and master's degrees in mechanical engineering. Phil's able to work with customers from the shop floor to the executive suite to define new products. A true passion for American manufacturing. And I know we can't give Phil a round of applause, but maybe we can clap on chat. But welcome, Phil. It's all yours.
Thank you, Tom. Well, good morning, everyone. I saw a lot of our customers as you were all logging on. We thank you for your continued business and support. Tom, I'm going to ask you to help me keep on the straight and narrow, because I've been known to babble and lose track of time. So please, please keep me moving along.
People that know me know that I'm a stringent timekeeper. I'll crack the whip, even though I'm not in the same room with you.
And Tom also gave my presentation a good eyeball a couple times and helped me whittle it down. So as Tom mentioned, I'm the product manager at Sunan Products for our honing machines and bore gauges, as well as our skiving and roller burnishing line and lapping machines. So I'm going to warn you up front, my application experience is not the greatest. So if I can't answer any detailed questions that you have, I will certainly take your information down and get you the information from our experts. So I'll keep moving here. So as Tom mentioned, we're going to talk about hydraulic applications for bore sizing, wobble pumps, cartridge valves, spool valves, hydraulic cylinders, all fit the bill. I like to tell people when I'm at a barbecue or a party and they say, what does Sunan do? I always tell them we make holes better. So with hydraulic valves, piston type pumps, and cylinders, as all of you know, there's a demand for closer tolerances, better fits between the piston and valve and the bore to reduce internal leakage, improve the performance of the component, as well as having surface finish control for seal life and performance. These design goals can be achieved with a variety of bore finishing methods. These are all secondary machining operations, obviously, after you've machined the part in a CNC machine. Then you can move to a honing operation or grinding, etc. So in my presentation, we're going to talk about some of the products our company produces. We're with, obviously, we've in the honing business for 96 years, 4 more years, and we're going to hit that 100-year mark. We're still privately held, headquartered in St. Louis, Missouri. We've branched out into automated lapping for high-precision aerospace control valves, and also skiving roller burnishing for hydraulic cylinders. I like to start out presentations with a slide, and many of you know this already, but I think it's interesting about what is a micron. And of course, being 59 years old and growing up in a variety of industries, I would prefer 40 millionths versus a micron, but just gives you an idea of a human hair all the way down to somewhat applicable now viruses, and how they compare in size helps put in your mind what we're talking about when we get into these tolerances. So as I mentioned, honing is a secondary abrasive machining process which follows the hole creation to achieve better bore geometry and surface finish. It's an effective alternative to ID grinding, precision and hard turning, and reaming. There are actually 2 types of honing. Many of you probably have both types in your facility. There's what we call single pass or single stroke hone, and then multi-stroke honing, which is the classical type of honing. And the selection is dependent on several factors, which we're going to get into later on in the presentation. Honing can correct numerous bore conditions that we'll get into, but it cannot change the center line of the part. The tooling follows the center line of the part. It can create a desired surface finish. The honing solution can be extremely simple or extremely complex, depending on the part requirements. The key parts of this process all have equal importance. My favorite part, the machine, of course, part fixturing. I'm sorry.
Just kind of, I was scribbling down.
The machine, part fixturing, the tooling selected, the abrasive for the job, very important, the type of cutting fluid, and then cutting fluid filtration. So this chart is, the next 2 slides are going to talk about just typical honing capabilities of what we can do, what we see in the marketplace, you know, the competitors, what the state of the art is at the moment. So diameter range, 60 thousandths to 60 inches. Bore lengths up to 47 feet. These are typically, in our experience, large pieces of tubing for the energy industry, which of course is not doing well either at the moment. These are big pieces of tubing that are honed out for instrumentation purposes and such. Bore configurations, you can have open, you can have keyway, blind holes, multi-landed, as with many valves, ported. Materials from Malenco to zinc, hard and soft steels, aluminum, zirconium, and then you get into exotic alloys, titanium, we hone carbide, glass, and ceramics, and various types of coatings. We're actually doing a lot of work in that realm at the moment. Stock removal can be 10 millionths to an inch and up to 20 thousandths per minute. Size control. So this is where honing can help make the hole better. We can hold tolerances to about 50 millionths. And as to back up a little bit, it is very application dependent. So many factors play into what you can do, from how tightly you have to grip the part to remove the stock, which can cause distortion, affecting all of these characteristics. but roundness to 30 million, straightness to 65, cylindricity to 80, and then surface characteristics. With RA, RZ, we can create plateau finishes. Often in the automotive industry, we work with plateau finishes. And then crosshatch angle. We can control that with honing to 20 to 120 degrees to plus or minus a degree for oil retention in the bore, seal life. We've even had difficulty sometimes with customers with seal noise in a hydraulic cylinder. So these are some of the typical bore conditions that can be corrected by honing. Barrel shape, bell mouth, boring marks, tandem bores. As I mentioned, it follows the center line, but you can help create straightness with those bores. Out of round conditions, what we call rainbow, reamer marks, tapered parts. These are all coming from the upstream process. Undersized components, obviously, and waviness in the bore. Now we'll talk a little bit, as I mentioned, there's two different types. Multi-stroke, which is classical honing. Either the tool or the part has to float in honing. The part is then fixtured or held in place to react out the torque imparted by the abrasive working the bore. The tool comes down, moves into the bore. It's rotating. The tool is also stroking back and forth, and the abrasive is being expanded by the machine by a variety of different feed systems. So you've got three things going on at once while it's going up and down in the bore. There's where the material removal occurs. At the end of the cycle, whether you're honing to time or you may have, we have a system called automatic size control on some of our machines where there's a hardened carbide plug that will drop in and shut the machine off when it gets to the right size. We have air gauging integrated in where the air gauge will feed back to the machine that it's at the right size. So many methods of doing that. Obviously, basic things like just stopping and measuring the part in some applications. And then, depending on the amount of stock you need to take out to get the part, the whole, to the correct geometry and surface finish requirements, you may have multiple operations. You may have a roughing operation, then a secondary finishing, and sometimes a third finishing operation, and even a abrasive brush that's run through the bore, especially with ported parts, to clean any burrs that may have accumulated in the ports, which obviously affect fluid flow. So it's just dependent on what your part is and what your requirements are as to whether can you do it one step or maybe 4 steps. Now I'll talk about single stroke honing. Single stroke honing.
Hey Phil, we have a question.
Oh, okay.
A question came in through the chat, and it was basically what is plateau finish?
I've got a slide on that coming up, but what it is, you'll have a bore where the abrasive has created grooves, valleys. And what you want to do is, this is, as I mentioned, typically in internal combustion engines for rings, piston rings, you want to knock the tops of those peaks off. So we will go in after the honing and we'll take a abrasive brush and go up and down in the bore a couple times, and that cleans off the tops of those peaks. And it does not typically affect the crosshatch. Depends on the abrasive being used. But it's typically, as I mentioned, used for a piston ring sealing in internal combustion engines. Does that help?
Well, we got one more question that came in, and
Okay.
I'll shoot this one, and you can decide whether it's appropriate right now. Do you see more RA or RZ requirements?
We really see both. RA is what I grew up with, but we do see, and actually there's more than that. I don't claim to be an expert, but we are seeing really more and more complex methods of describing the surface finish that's desired in different applications. So I hope that helped a bit.
Thanks, Phil. That's the questions we've got right now. Thanks.
Okay, thank you. So with the single stroke process, as I mentioned, it's very similar. You got to hold the tool, or excuse me, the tool or the part's got to float. So you've got to also fixture the part. And when I talk about the part floating, sometimes, and especially in single stroke, you've got the tool in a solid connection in the spindle. And the part is retained in a fixture, and we'll get into fixturing later on. And there'll be float built into the fixture to allow the part to move, to allow that honing tool to follow that center line like it's supposed to and help create that geometry. So in single stroke honing, the tool is actually a plated, diamond plated sleeve, and it's preset to a diameter. So there is no, at least in our world, and I think perhaps some competitors have automatic methods of feeding tools up, but ours are manually set. Now these tools last many parts. Some of them can last 100,000 parts. Well, the tool is rotating and then is pushed through the bore by the machine. And it's just one pass, hence single stroke or single pass. And that's where the material removal occurs. You're pushing that diamond plated sleeve through, then you back up, and it could be one tool. We've actually had our tools put into CNC machines where the CNC machine can hone the part with a single pass, or it could be, it takes 6 operations to get your geometry. And we're going to talk a little bit about when you want a single pass, what parts are applicable for that versus multi-stroke. So a comparison of the methods, single pass versus multi-stroke. The things that come into play are the part material, the length to diameter ratio, the amount of stock you want to take out, the chip formation that occurs, which is material dependent and stock removal dependent, burrs, which are critical, of course, in hydraulic components, and what type of surface fixture, or excuse me, surface finish and texture are you wanting to hold, because there are limitations. So with multiple stroke honing, we talk about materials, it's really the gamut, depending on the abrasive selected. With single pass honing, what you're looking for success is materials that produce small chips, because that, and we'll get into why that's important. And those are cast iron, powdered metals are excellent candidates for single pass. Ceramic, glass, graphite, you can see they all have the same, you can envision that they're just small chips when you're machining through that. Now limitations are softer materials, aluminum, brass, stainless, Inconel. These cause stringy chips, which cause problems for single pass. Length to diameter ratio. For multi-stroke honing, really anything's possible. And if you have very short parts, for instance, let's say a connecting rod for your small 2-cycle gas trimmer or chainsaw, the part can become unstable. However, you can stack them. Same with gears. So with multi-stroke honing, really, once again, very flexible depending on the fixturing stuff. With single pass, it's best suited to length to diameter ratios of 1:1 or less. Larger ratios, if there's bore interruptions, allow the chip flushing through the cross holes and such. Now, burr formation, which is very critical with especially hydraulic ported components. The least burr is with vitrified abrasives and multi-stroke honing. That's your least risk of creating a burr. Larger burrs are with metal bond abrasives and multi-stroke honing. The largest burr created is with a single pass diamond hone. With honing stones, and we'll get into some more detail in a bit with those, they wear away and they're constantly exposing new grit, which is continuing to cut. So you've got multiple layers of free cutting grit being exposed. Whereas a single pass diamond tool, it's got one surface of diamonds which have been selected depending on your stock removal, the surface finish you want for the part. And as I mentioned, you may do it with one pass, you may take 6 passes of that part progressively getting bigger. Well, the single layer of plating cuts less freely as it wears. As you can imagine, you've got this layer of pointy diamond that works great when it's brand new out of the box. It's cutting away. Well, as the wear occurs with the diamond, it doesn't pull the diamonds out because there's nothing under them to expose new diamonds, just single layer. Well, then it becomes harder cutting. The surface finish can become finer with this, and you get burrs in hard and soft materials that form, especially in your ports. So surface finish, multi-stroke honing. As we mentioned, you can control the crosshatch if you have requirements for seals. You've got good bearing surface, oil retention. And as I talked about how the abrasive works, it's consistent over the entire life of the stone and the tool. Whereas single pass honing, you get a tight helical surface texture pattern, which is very evident when you use this for parts, and it may be acceptable. Progressively finer surface finish, as I mentioned, as this single layer of diamond gets worn smooth. So back up a bit. If your part is a candidate for single pass honing, it is by far your lowest cost per part. As I mentioned, out of a good set of tools, you can get 100,000 parts, but you just have to be careful about, and our expert, talking to our application experts can help with that, is the part the correct candidate for this type of operation, or do you need to go with the multi-stroke operation? Now we're going to get into the bits and pieces of the honing solution, and my favorite part, there's lots of machines. So you've got horizontal machines, vertical machines, tube honing machines, as I mentioned before, and those can be used for hydraulic cylinders, either production or repair, as well as I mentioned the energy industry with these huge pieces of tubing that are used in oil wells. And then you can actually have a human who's the honing machine. For some applications, very large parts and repair, you can take a drill and you're the machine, stroking it and honing the material out with a portable type tool. The selection depends on the following. The primary thing is, what is the required process to hit your dimensional requirements and your surface finish requirements? It could be one step, it could be 4 steps as we talked. The part shape, size, and weight. Obviously, if you have a part that weighs 30 pounds, some big cast iron spool valve assembly, well, you can't put that on a horizontal machine because the weight of the part, it would be difficult to fixture and keep. The weight would not be working with you. You'd want to work with the vertical application. Production volume. You can have a small manual machine. Maybe you're making 10 parts in your prototype department. You just need something that's flexible to make a few parts, all the way up to creating hundreds of thousands of parts annually for high production work. Tooling requirements, the same thing. There's and we'll get into that in a bit too. There's tooling that's well suited for low production runs, and then you've got extremely high production tooling that is hardened, machined, super abrasives are used in it that can last for hundreds of thousands of parts before it needs to be reworked. And then you've got part load and unload requirements. It may be as simple as you're standing there honing, putting the part in and out of the machine and into some simple fixture. Or it can be as complex as having a robot loading and unloading parts. And we've even integrated in the past stations pushing a pin into a part, or having some additional assembly that occurs after the part's honed. So this recipe, if you will, is critical on so many different things that have to be analyzed to create the most cost-effective solution to make sure that your costs are minimized to create the part that is for your application. I've got a few slides here just showing from our line of machines to give you an idea of the variety. These are horizontal machines. Many of you may recognize the machine on the upper left, the MBB. The design's been unchanged for about 60 years. So they're out there in a variety of colors. You move through different horizontals. We've got a wide range of verticals. I mentioned large, heavy parts. Upper left is a machine that's typically used for remanufacturing car engine blocks because of the weight, as I mentioned. Then we've got in the middle at the bottom an automated solution. That's a 3-spindle machine because that's the number of steps it would take for this particular component. We've got a robot, we've got a pressing station, perhaps a cleaning station. And then I talked about tube hones. We make a variety of tube hones, as do our competitors, for different applications. Now we'll get into the real key to success. The abrasives, tooling, and cutting fluids, these are all working together. And just to give you an idea of the complexity, and this is just at my company, we actually have approximately 7,200 different types of tools you can order, 21,000 different abrasives, and 19 different water-based and oil-based coolants that are required. So once again, it gets back to your application and honing in, no pun intended, or perhaps it was, on the right solution. As I mentioned with tooling, these are just some examples of typical tooling. In the lower left corner is our venerable K-line. These are flexible tools. A lot of job shops use these tools. They're relatively inexpensive. They have a lower life, but they're good for lower production, flexible applications. The tool just above that is a heavy-duty, high-production tool for engine remanufacturing. So you can see there's a wide variety of tools, once again, dependent on your application. Abrasives, we've got super, conventional, and diamond-plated. And I'm going to get into a little bit of the detail, and you'll have to bear with me. I am not the abrasives product manager, and he couldn't be with me. So just got a few pictures there. We did talk about the diamond plated tooling used on the single pass. You can get a little better idea of that at the bottom. And you can see the helical shape, that single coating of diamond. The tool third in from the left, you can see the adjuster, which there's a taper, and you adjust as the diamond wears. You manually turn that cap up, if you will, to drive that abrasive sleeve up a little bit further to maintain your size until you wear the tool out. How do abrasives work? An abrasive stone is typically what we use for stock removal, obviously. Cutting tool needs to be harder than the workpiece, of course. You're not going to remove material. So some of the hardest materials known, I've got listed there, diamond, borazon, and so on, are what go into that recipe with our abrasives. The abrasive stone consists of a mixture of abrasive grit particles at a certain size, depending on the surface finish and stock removal requirements, and then a special bond that holds that all together, a glue, if you will. And we have different bonds and different hardnesses of bonds. Each of those many small abrasive points that are on the stone, those are exposed as the bond wears away, and I've got a slide that kind of shows some of that in a bit. That bond is made to, as the grit becomes worn down, the forces go up on it, and the grit will actually pull out of the bond. And the bond wears down and exposes new grits. So you've got nice new sharp teeth underneath there ready to take the place. Now this is where you get into what we call swarf, or many of you, if you've been around honing machines, the mud that comes out of them. That's a combination of this abrasive wear as well as the material that you're honing and the bond that's wearing away. So these abrasive grit particles are performing the cutting action. As I said, they wear down, pull out, and expose new grit until you've worn the stone out.
Hey, Phil, we have a question.
Sure.
The question is, how frequently are these tools checked or calibrated?
Are you, well, that's a good question. So it really depends on what you're doing with the tool. We have customers that are doing very high production work, and we make a line of, we call them MMT tools. And our customers work with us, and we've developed the number of parts that they should send the tool back in, or they can do it themselves, but a lot of them send them back into the factory, and then we will put them back in the cell that built them, and they'll inspect, and they'll grind and replace components. The tools are designed often to have replaceable components. So I hate to be evasive, but it really depends on how much you're using it. And we provide dimensions in our catalog, like on the K-mandrels. You can take a set of calipers and check them periodically. Typically it shows up because you're having problems. You'll get stones that are wobbling in the groove, and you'll see issues and visibly see the wear in the tool. So it's really making sure your operators are attuned to problems and then getting that tool checked. We've had problems in the past with some of our really heavy-duty large tools for high stock removal in the oil industry, where there's actually a cone inside that expands the abrasives, and the customers won't check it. And this swarf, as I mentioned, it's a nasty substance, and it can get rock hard, this oil and worn abrasive and the material you're cutting. Well, it'll work its way into that, and then the tool starts binding when you're trying to have the machine expand. So as I said, it's really being aware of how the system is working, and then when you have a problem, I always recommend, of course, because the machines are perfect, start with the tool. But seriously, you want to start with the part that's exposed to all of that wear and tear. So I don't know that I'm helping a lot there, but certainly if you're a high production customer, we do offer, or we can help you set up a typical inspection procedure based on number of parts our engineers can recommend based on the wear. So any other questions at this
thanks,
time?
Phil. Yeah, one
Okay.
more question came in.
Okay.
What does MMT stand for? Mentioned MMT tool.
I believe it's multi-mandrel tool. And since I'm not the abrasives tooling guy, we come up with things we like: LBT, long bore tool, DH, which I don't even know what that means, K, which was old. They tend to be alphabetical, and a lot of them don't really mean anything. It's just a numbering system at the plant, but we have families. So MMT is our high production, small bore tooling line. They're hardened, they've got replaceable wear pads and such. So I hope that helped a bit. If you look in our online catalog or good old paper catalog, which I like, it'll describe a lot of that, but I don't know that MMT actually means anything. So, any more?
Thanks, Phil.
Okay. So as I mentioned, each grain abrasive is separate cutting edge, and it affects cutting through the machine is imparting force to all those little points. You know, you've got the power of the spindle, you're turning, you've got the machine stroking, or in some cases, the human is stroking the part, depending on the type of application and machine. But this is just a force diagram with the particle showing how you're pushing it, bulldozing it through that material and pushing that, creating that chip. You've got elastic deformation, plastic deformation, and then the actual shearing of the material. And as we discussed on conventional type abrasives and super abrasives, not the diamond, or at least diamond plated. We do make diamond abrasives too, we'll get into. That cutting particle starts wearing down, just like your lawnmower blade or in your CNC machine. So the force will start going up that the machine's imparting to that, and it will help pull that worn cutting point out and expose a new one. So they're self-sharpening, basically. Now this is a little section out of our catalog. It's an abrasive selection guide, just to give you an idea of some of the types of abrasives, and it gets rather complex. We've got, when we set up an abrasive, you've got the type, which is dependent on application, how many parts, high production, low production, keeping the costs down, you know, silicon carbide, diamond, CBN or super abrasives, and then your grit size, which is critical to the surface finish and stock removal. And this is where we get into, you may have a grit size that's very aggressive for your first step to take a lot of stock out and get that hole rounder, straighter. And then the next step may be a fine grit to help you get that surface finish down and get to your sealing requirements. And then the hardness is actually the bond. And you have soft all the way through hard bonds. And once again, this is based on how hard you're having to push that tool. Are you taking a lot of stock out? Or are you not? That bond hardness is part of the equation of how the grits are replaced as the process is going on. Now, a lot of this we developed over the many years of being in the business. Hence, a lot of this in our catalog is based on our years of experience, what I'm trying to say, on applications when we look at materials. Many years ago, we had an engineer named Hans Fischer, and he spent the bulk of his career working in a laboratory with every type of material imaginable and trying all different recipes of abrasives and bonds and grits. And a lot of the data we have, even though it's 20 years old, is still applicable today to the alloys that are still in use. And we continue that work. He actually created a book called Honing with Hans, and we rely on that a lot when our applications people, either in the laboratory or the applications engineers, are looking at your type of part as to what do we need to use. So a lot of this was derived on experimentation as well as theory and engineering work. So we talked about the different types of abrasives. I mentioned super abrasive. We've got what we call conventional or basic abrasives. They're cheap, they wear quickly, and we've got super abrasives that don't wear so quickly. And these are a couple of just some things that go with that. The type of abrasive, and we'll talk about the coolants here in a bit, but if it's a vitrified bond, you have to use oil. You don't want to use, you know, we produce water-based and oil-based coolants. Oil does the best. We make some stuff called MB30 that it has animal fat in it, which works great. It was developed years and years ago, and it does the best job. It smells horrible. You get it in your hands. You have oil on your parts, which then you have to clean that off before you go to the next operation. So oil is the best, but we realize water-based had to be developed to work with our customers who don't want to be cleaning parts constantly and have the issues that go with oil. And in some parts of the world, you know, oil's not a good thing. We've designed our machines to not have leaks with coolant systems and such. And there are places, especially like the West Coast, has some pretty stringent rules on the type of honing oils and coolants you can use. So the selection of that also depends on the type of abrasive. And I'm getting off track here, and we'll talk a little bit more about the coolants.
Hey, Phil?
Yes,
Phil?
yes. Am I running out of time?
You got a total of 15 minutes left,
Okay.
including some time for Q&A, so I might want to finish your presentation within like the next 10 or less.
Thank you, sir. I will kick it up a notch.
Don't mean to be rude, but I'm the timekeeper.
At our sales conferences, the sales manager usually has a soft ball, and he throws it at me in the middle of it when I'm getting too close to the end. So
yeah.
Anyway, we'll keep going here. I've just got a few slides to show you about the type of abrasives and materials. These are diamond, not to be confused with diamond sleeves, but these are actually diamond that can go in an abrasive stick. Some of the materials that they're applicable for. Borazon or our CBN, super abrasives. Another talked about, got to have hard material doing the cutting. Conventional abrasives we talked about. These are for low production and softer materials. They wear, but they do a great job. And sometimes they are required in order to get the surface finish and the requirements that your partner needs. Talk a little bit about diamond plated tooling. I think I've kind of beat this horse. We talked about one layer, single layer, it's nickel plated on, stock per pass limited by the ability of the chips to get past those grits as the tool is being forced through the part. These tools, as I mentioned, very aggressive when new, and then the surface numbers decrease. The strain on the part goes up. The machine is using more power as the tool wears. And the performance in water is about 30% of that, of what you get with honing oil. We talked about plateau honing. On the right is a graphic showing that. You're knocking those peaks off, and that's typically with piston rings and engines. You want to have that area where that ring is riding on in the engine block. And then crosshatch control, you can maintain depending on your sealing. A lot of your seal companies will recommend a certain RA, RZ, and the level of that inclusive angle. Talked just about crosshatch angle. You can change that with the machine. You can, on some of our machines, you just program it in. On others, where you're doing the crosshatch, the stroking, high speed, you can see what it looks like. Low speed, it reduces that inclusive angle, but it can be manipulated depending on your requirements. We talked already about honing fluids. These are some problems we see, and the honing fluid is often a very neglected part of the process. It needs to be maintained. We have filtration units, or can recommend that for people that have centralized cooling systems. There are additives that get depleted. The water base, you get biofouling in it. And we've actually seen people use kerosene and stuff, which is not good. I mean, there's a reason. Then you have problems. You have abnormal stone where you have the stone breaking, pieces coming off. You'll have metal welded to the stone. And you'll have, especially if you're doing it the old-fashioned way in one of our MBB machines, and you've got your hands on the part, you'll feel it grab. And that's due to problems with the fluid, typically. When we talk about this, we make a chart called the SMOPS chart, and we give it to customers, and these are just things to check when you're having problems. Is the stone right? Is the mandrel right? What type of oil are you using? Is your feed pressure for pushing that abrasive out and through the part correct? Are your speeds right? Effective varying machine parameters. If you increase the stroke speed, you cut cycle time, the stone cuts better and faster. You get a bit wider, that crosshatch angle goes up, as I indicated, but you get faster wear of the guides and the stone. If you up the spindle speed, surface roughness can decrease, crosshatch angle decreases, and the stone, as we say, acts harder. It will vitrify or get harder sooner from that pressure going on. If you jack up the pressure, the feed pressure of the machine, the honing stone will cut better and faster, but it also wears more. So you're looking for those optimum settings to, once again, minimize your part costs, minimize those consumable costs. We talked
Hey,
a little
Phil,
about,
Tom again.
yes, sir.
10 minutes.
Okay, thank you.
Yep.
Part fixturing, just to give you some ideas, you can have it, you're holding the part in your hand, all the way to some of the pictures here that are for high production solutions. Now, I've left the last two processes, the end here, I just have some overview slides. Automated lapping. So we all, I think, know what lapping is. Most of it's done manually. There are surface laps, but we're talking about bore lapping. So this process goes beyond the core capabilities of honing. It delivers cylindricity to 60 million, straightness to 40, roundness to 15. This is typically a labor-intensive manual process. The unit that we developed is automated. We have some patents on it, and it was really developed, 9 years of development for the aerospace industry. These very expensive aerospace control valves. where you don't have to actually have people doing it. So we'll get into the benefits are improved consistency of the finished parts, reduced reliance on people, improving safety by eliminating people's hands on the parts and in the machines, because that's how a lot of these are done, by feel, the human touch of feeling when the bore is right. And we're able to tighten the tolerances. And that's a picture of the automated lap machine and then the lapping tool itself. But the machine will actually put the part in and walk away. It air gauges laps, continually measuring the part and washing it. Now we'll get into our skiving and roller burnishing system. For those of you that are not familiar with this, was developed by a company, Sierra, in the 70s for speeding up and replacing honing machines. We competed with this for many years, and hence why we brought it into the fold. It's really geared towards very high volumes of tubes. And how the tool works is you've got two parts when you're looking at that tool. You've got cutters on the front that are skiving, taking that material out, and right behind it are rollers, hardened rollers that are smashing down those peaks and valleys from the skiving, the cutting, and creating a mirror-like surface finish. And as I mentioned, this was developed in the 70s. This is 70 to 80% faster. There was a newspaper article, much to our chagrin, many years ago, that at the John Deere plant, 2 skives replaced like 23 honing. So it can hold diametral tolerances to 1,000. It is a very large investment. This is not for the faint of heart with capital expenditures, and it is for very high volume tubing production. But it more than pays for itself if you've got that application. 2 processes and the tools I mentioned, I went over what you can do. The surface finish can be an issue for seals sometimes. It's a mirror-like finish, and there really isn't much you can do about it because it's created by those rollers. You do get a residual stress layer from the burnishing that gives you a good wear for your seals and your piston and your cylinder. And how it works is you clamp it in the machine, the tube on either end. You're flowing huge amounts of coolant through that tube around the tool and pushing all these chips, because the chip, you're talking perhaps a 2-foot, 3-foot long cylinder being done in a matter of seconds, 30, 40, 50 seconds. So you can imagine the chip load. So quick summary slide. Owning single pass and multi-stroke options, size control to 50 millionths, there's your geometric tolerances. When you need a closer fit than honing can provide, you've got lapping, whether you're doing it manually with the human touch or with an automated system. And then when you need to produce those high volumes of hydraulic cylinder tubes, you've got the skiving and roller burnishing process, 70 to 80% faster than honing. I'm done, Tom.
Hey, Phil.
Hey, that's pretty perfect, Phil. We got 5 minutes left for some Q&A. So
We have a couple.
Pete, do we have any questions out there?
We do.
I'll do my best.
One of them might actually be answered a little bit by this slide. The question is, what surface finish requirements, what surface finish measurements does someone measure, and which ones are the most important?
Let's see. I mean, we actually don't make surface measuring equipment. We have it in our laboratory, and we recommend customers have it. I don't know if I'm answering the question. I mean, we can control it, but there's plenty of companies out there that make, Mitutoyo makes a unit that you can lay in a part. It'll actually pull what they call a skid along and give you your surface finish requirements. In my experience, surface finish, especially in hydraulics, and you folks would know better than me, is driven by the seal manufacturers, the sealing requirements as to what they need for oil retention to help with seal wear, but you can't have too much, obviously. And as I mentioned, with RA, RZ, and some of the other ones, which I don't even claim to be an expert in because they get pretty complex, especially when you get into automotive and diesel engines. We do have the capabilities to control all that, but we we make bore gauges, but we don't make surface finish equipment. Did I answer that?
I hope so. I think that was pretty good. Thanks, Phil. Another question. What % of Sunen's customers blind hole hone, and what are the best practices for this process?
I don't have a percentage on blind hole. There's a lot, I'll tell you that. First, when you design the part, if your engineers can work with your manufacturing people, and we will even offer to sit down with your design engineers, if you can have a relief in the bottom, if the part has that capability to have a relief where the actual stones can move into that relief and then back out, because what happens is you're going to get a tapered part, as many of you probably know, with a blind hole. Now, what you can do also is we make special mandrels, or you can take our K mandrels and cut the ends. We'll even show in our catalog how you can modify the tool to help with that taper, and it really gets the abrasive right to the edge of the tool. Because for straightness, in the perfect world, you want to go all through the part about, I think, 2/3 or so of the abrasive length, and then come back out the top. And that helps you get a good straight part. Well, the blind hole, you can't do that. So you want to maximize your abrasive contact. So as I said, we make special tools for that, but you can also modify tools to get the abrasive right up to the end. And we even do things like we make some hard tipped abrasives that help, because you can break it off when you hit the bottom, basically. So there's solutions for that. I don't have a number for the people, but it's a common issue. But if you can get your engineers up front to think about how that part's going to be made without adding a lot of cost, a relief at the bottom is a big, big help to keeping that hole nice and straight.
Thank you, Phil. We got a couple other comments that came in off the Q&A or the chat. Dan Schoolin is mentioning that he's presenting later on some information on surface finish.
Yes, a Brennishaw, of course.
Yeah. So another reason to stay tuned for later this morning. Dan will be talking about that in his presentation. Also, somebody asks, does Sunen work with quality control and process capability of the OEM's top-tier hydraulic suppliers to make sure manufacturing equipment is running optimum?
Of course. Yeah, we do pride ourselves on our applications and field service people, and we are always available to come in and audit your processes. Like I said, don't want to do an advertisement for my company. We have many worthy competitors, but in the U.S., all of our salespeople, our sales engineers are well trained, and that's your first step. They can come in and take a look, and most of them have a lot of experience. And if not, we send teams of people in. So we are happy to audit a process, and it'll help you get back on track, and maybe we can make recommendations for improving your abrasives to get your costs down, have better life of the abrasive. As I mentioned, I have seen many, many issues with the coolant systems. People sometimes think, just throw that kerosene in there, it'll do the job, but it doesn't, and it costs a lot of money and a lot of problems. So I hope that answers your question. We are more than happy to help with OEMs getting their processes fine-tuned.
Thank you, Phil. That's all the questions we have right now.
Okay.
Well, that's great, because we're right on time too.
That's shocking, Tom, and you didn't even have to throw a virtual ball at me.
Yeah.
Well, thank you, everybody. It's been a real pleasure. I appreciate the opportunity from NFPA, and on behalf of Sunen Products, all of our customers out there in the audience, we thank you for your business, and we hope you're getting back up to speed, and we're there to be behind you. Our plant's up and running. Most of us are working from home that can, but we've got production up. We put in some guarding and stuff to keep people apart, move people spread out to 3 shifts. So anyway, thank you again.
Well, thank you, Phil, on behalf of the Fluid Power Industrial Consortium for this presentation. I learned a lot, and we appreciate your time and effort.